Welcome to a new test and teardown video. Here is a Stanford Research Systems model SR850 DSP lock-in amplifier. This one is really interesting. It's able to analyze all sorts of audio range, but you can also do filtering and input-output analyze of phases and signal levels, harmonics, whatnot. It's really crazy, and it goes all the way to very few millihertz, all the way to 100 kilohertz. And it's of course completely computer, and there's a disk drive for storing stuff, and we got, let's look here, the inputs, the outputs, sine wave and references, and you can of course set up everything here on all the push buttons and whatnot. Disk drive, it's also really interesting. It's probably DOS format, I hope so. Well, I definitely want to open and inspect before we go any further. The size of this is just like an old AT or XT personal computer from the 80s or something like that. This is really big. And here we go at the back. Look at that. It definitely looks like we got a PC inside. Look at that PC keyboard. The 8088 style printer port and serial port IEEE. And we got quite a lot of auxiliary inputs and outputs and all that kind of stuff. X and Y monitor. Maybe that is a composite video. Let's definitely check that out. So that was real easy, and now we're inside, and the first thing I see is it's really compact. I believe that will be, of course, all the power supply stuff. That will be the screen, but there's a really funny thing. Look at that little extra lid on top of this CRT. What is the purpose of that? And then over here we got some plug-in cards for different types of measurements and whatnot. I really think this is just a PC down here or something like that. I will see if we can pull out the different boards and see what's going on. It looks like there is room for another plug-in card, and that will be the disk drive, and it seems like it's empty out there, maybe. Okay, I think I figured out something. So of course this is the power supply, and at first I had the idea just to unscrew these and then I should be able to pull it up, but this is not at all how you do it. And there is a reason why I figured this out, because there's a heat sink right here, and this heat sink, see, all the transistors, they're soldered to the circuit board, and then they're screwed into the heatsink. So of course there's no way to pull this up like that. It's not how you do it. So there's another way. So I'm trying to figure out how to open it a little bit more. But so far I'm just looking in here at the bottom. I really like the way that everything here is shielded and protected, and it's really kept good and stable. And the flat cables. So this is from the floppy that goes up here, and look at how the different plug-in boards they are connected together with also flat cables, and then like that. And from the rear, the BNC connectors. You also got some cables that goes up here to the front and all that. And then, oh, did I show this little label I found inside? See, in 95 it was tested. So maybe this is the factory last little test. And here is what I believe is the motherboard. And what do you think that big IC is? If we think about 1995, I think this one is the 68,000 Motorola CPU. A big, hefty 32 16 bits CPU. And if you also look at some of the other chips around here, it looks a little bit like an Amiga 500. How cool is that? So I decided to take away the side panel, and that was very, very difficult as well. And because it's locked in with all the different screws from top and from bottom, and also the way they made the wires lock into everything, and also the power cord was also pressed in. You can probably even see here how hard it was pressed in between some metal parts. So I didn't want to break anything here because I definitely want to play with this unit. Hopefully I can get it up and running, but first I want to see if we got any leaked or brown or blown up parts. And here is the power supply cooler. Look how beautiful that one is. And oh my god, look at that. Can you see the fan? The screws, they over tightened those, so the whole fan is just more or less, oh, that is dumb. They were not supposed to tighten that much. They should have used a little rubber disc or something. No, this is really, really dumb. I don't know if you can see. Yeah, here you go. Now you can see how bad it is. No way, man. But other than that, it's really, really clean. And I think I've figured out how to open it. I can see some more screws down there, and then I think the rest of those screws and those here. Here we go, and then yeah, let's see if we can go and inspect the power supply and the main CPU board first of all. So I was finally able to get the entire CPU card out like this. I don't want to pull the rest of the cables, but this is what we got so far. So here's the parallel port that would go in there. They even say printer and keyboard and all those kinds of things. And this is because this is of course not a normal PC, but this is a specialized PC for this one, of course. You can even see here it's called Stanford Research Systems. And I was wrong about this unit. See, it's an HT63484, and this is probably graphic interface. That's just what I'm guessing, because this is the connector for the CRT, and here we got H and V sync. For that, it's maybe just a VGA or something like that. Probably not even color. It's supposed to be just green. We got all the RAM. So this is looks like it's 16 bits, and we got 4 big EPROMs, the 27C010. So it's 1 megabit per EPROM. And here is the main brain. It's the 186. And then we also know a little bit about the age, because I can see on the other ICs here they're from 92. So yeah, now we know a lot. Oh, here is the classic IEEE interface. That's a power supply, and it's really nice with everything written here with all the different voltages, and it's also really good explained on the power supply board on the top what is what, and good things like that. So the only thing I want to do is just to measure what is the voltage on the backup battery, and then I think I'll put it back together and hopefully power it up. So here's the DSP56001, and yeah, this is probably just the little interface and support chips for it. Maybe we got some RAM up there, or maybe those are EPROMs. Definitely some programmable memory or something like that, right? So what else can I say about this? Of course, this is the analog input-output sampling and DSP thingy board. We got some PCM 1700s right there. We got all the opamps and yeah, all that kind of stuff. This is probably isolated clock, and they're using RCA connectors. And yeah, why not? And this thing is from 0 to 100 kilohertz, so it's not a mini megahertz or gigahertz kind of thing, but still it's built almost like something like that. But down here we can see the connectors for that, and definitely upgrade possibilities for some other plug-in boards. It is also a multi-layer board. I haven't yet found the layer identification, so I don't know exactly how many layers we got. I can only see this component side, and then you have solder side. And the layout is nice and beautiful. Good extra ground connectors. And here we can see the isolated signal like that. We can actually also see some internal ground planes and all that kind of stuff. Early cat with the 90 degrees and 45 degrees mixes, and yeah. See those ground connections, they go in the little extra copper connectors like that. Pretty nice design. I think there must be some really interesting specifications to this unit, because you can see we got a shield wall here, and there's another shield box with a little top lid, and then inside we got another shield box on both sides. I mean, they mean definitely something here, with some isolation figures and stuff like that. Local supplies and so this is the login analog board. See, here we go, 1992. I was right about that. What a beautiful design. Silk screen identifications on the bottom side for everything, for easy figuring out what is what. But I still haven't found one lead component. We gotta open this little room here. Let's open this box and, and enjoy what is in there. Well, let's do this together. Nah, it's not super impressive. Just some op-amps and some relays. I thought they could have been even more sexy, but it's just fancy smancy power supplies for that. Well, there you have it. So let's put it back together and see if it runs or smokes. If you go to the Stanford web page and look up this SR850, you can find a lot of additional information about my unit. Also, it looks like they still sell this one for about $10,000. We can see all the detail about how the DSP is doing this and that, and how many samples and 18-bit of AD resolution and whatnot. I think you should just hit pause, and then you can read all the details here. You can also just go directly to their webpage. I should probably just put in a link in my description to their webpage, so you can go directly to all this information. I just keep it here in case they take down this site or kill this page or something like that in the future. But here we can see a little bit about the different traces, the different displays, how it can do math on the different inputs and phase this versus that. And I really hope to be able to get just some of this up on my screen during the next few days. That will be fantastic. So here we go with the first power up. Let's first make sure that I am ready to pull. It's going beep. Oh, we got green light. Look at, oh, we got a beautiful screen. Oh, that is a nice resolution of that screen. Look at that. I better go and, sorry about this, but you gotta see this picture. It is so nice and beautiful. Wow, I need to go and see if we can get some signals in and out, but I think I will now need to read the manual a little bit about what exactly is going on and how do I operate this one. So the first thing to play with is to input a signal. So this is 1 volt RMS, 1 kilohertz, and if I plug this into input 1, that will be X. Okay, I don't know exactly what I did, but now it's doing different. Before, it was the other way around. I think it was auto range or auto gain, whatever it was I did. Auto scale. Oh, here we go. Now it's back. So now X works. It's showing almost this one. See? And then I think the idea is, see, now nothing is here. And then you just auto scale on that. I don't know exactly. I think input, you see this input here is not working. So that is why we see also this crosstalk problem, because there's nothing in this input, but that input here seems to be working like that. Auto gain, yeah, here we go. Fantastic. So it is more or less up and running. It can detect some signals. We can of course do all sorts of plots and traces, and we can do all sorts of things that is not super yeah, I'm not super into any of these things yet. It will take me a few hours to figure out what to do here. I found all sorts of fancy system test menus in here. See, we got a memory check. I just passed all memory checks. We can also check the video memory. Then it will do like that. Return that. Return that. We can also test the screen and it will do something like that. How cool is that? Here's a real cool feature it can do. So what it's plotting right here is the phase and amplitude relationship between this sine output and an input, right? So my input here is coming from a signal generator, and the output from this unit here goes to my scope just so I can monitor. And it's very close to 1 kilohertz, and this one is also very close to 1 kilohertz. So what is going on here is they are of course not locked to each other. So what you see here is the super slow phase shift between the input that I come with and its own reference. And once you hit auto phase, it will 0. See? Then you are back, and then you start to drift again, and then you can monitor phase. So this is useful if you want to monitor phases between two signals. Isn't that sexy? I kind of like it already. I'm looking at the different charts it can do in the different phase chart bar. There's only the level like that, and then you have it blank, and there you have the polar or phase. Anyway, I don't want to talk so much more about this unit. It's just real funny. Phase angle level meter, and I still think that one of the inputs is broken, so that is of course why I got this one. So I think this is what I wanted to talk about tonight. So thank you very much for watching. Bye bye.